Welcome to our journey through the wonders of Saturn, the sixth planet from the Sun, and the second largest in our solar system. Saturn, often recognized by its stunning ring system, has captivated human imagination for centuries. From early telescopic observations to modern spacecraft missions, Saturn continues to reveal its mysteries to us. We'll start with its basic characteristics, delve into its thick atmosphere, and unravel the secrets of its mesmerizing rings. So, buckle up as we embark on an incredible voyage through this ring giant's many wonders. Saturn is a gas giant similar to Jupiter, but with its own unique set of characteristics. It boasts a diameter of about 120,536 kilometers, making it roughly 9.5 times the diameter of Earth. Despite its massive size, Saturn is composed primarily of hydrogen and helium, giving it a relatively low density. In fact, if you could find a large enough body of water, Saturn would float due to its low density. A day on Saturn, or its rotation period, is incredibly short, only about 10.7 hours. This rapid rotation contributes to its noticeable equatorial bulge, making it an oblate spheroid. Saturn's orbital period, or the time it takes to complete one trip around the Sun, is approximately 29.5 Earth years. Next, we'll dive into the layers of Saturn's thick atmosphere and the dynamic weather patterns that make it so intriguing. Saturn's atmosphere is a complex and dynamic system, composed predominantly of hydrogen, around 96%, and helium, about 3%. Trace amounts of other gases like methane, ammonia, and ethane are also present, contributing to the planet's unique characteristics. The upper layers of Saturn's atmosphere are divided into several distinct cloud layers, each composed of different substances. The uppermost clouds are primarily composed of ammonia ice, giving Saturn its pale yellow hue. Below these clouds, you'll find layers of ammonium hydrosulfide and water ice. These layers create a striking appearance, often seen in the form of bands and zones that encircle the planet. Saturn's atmosphere is also home to some of the most intense storms in the solar system. The Great White Spot, a periodic storm occurring roughly every 30 years, is a prime example of Saturn's dynamic weather. As we move forward, we'll shift our focus to the most iconic feature of Saturn, its magnificent ring system. When you think of Saturn, the first thing that likely comes to mind is its awe-inspiring ring system. These rings are composed primarily of ice particles, ranging in size from tiny grains to large boulders. The rings are incredibly thin, despite their vast expanse, stretching over 280,000 kilometers in diameter, but only about 10 meters thick. Saturn's ring system is divided into several main sections, the A, B, and C rings, with additional fainter rings like the D, E, F, and G rings. Each of these rings has its unique characteristics and particle composition. The Cassini division, a dark gap between the A and B rings, is one of the most prominent features and is created by the gravitational influence of Saturn's moon Mimas. The origin of Saturn's rings is still a topic of scientific debate. Some theories suggest that the rings formed from the remnants of a shattered moon, while others propose that they are leftover material from the planet's formation. As we continue our journey, we'll explore Saturn's powerful magnetosphere and the auroras it creates, adding another layer of complexity to this fascinating planet. Saturn's magnetosphere, the region dominated by its magnetic field, is one of the most powerful in the solar system. Generated by the movement of metallic hydrogen within its interior, Saturn's magnetic field is about 578 times stronger than Earth's. This magnetic field extends far into space, creating a vast and dynamic magnetosphere that interacts with the solar wind and Saturn's moons. One of the most fascinating aspects of Saturn's magnetosphere is the auroras it produces. Similar to Earth's northern and southern lights, Saturn's auroras are created when charged particles from the solar wind collide with the planet's magnetic field. These collisions excite the gases in Saturn's atmosphere, causing them to glow in vibrant shades of ultraviolet light. The magnetosphere also plays a significant role in shaping the environment around Saturn. It helps to trap and accelerate charged particles, creating radiation belts similar to Earth's Van Allen belts. As we delve deeper into Saturn's system, we'll explore the diverse collection of moons that orbit this gas giant, each with its own unique characteristics and mysteries. Saturn is home to a diverse collection of moons, each with its unique characteristics and mysteries. The most famous of these moons is Titan, the largest moon of Saturn and the second largest moon in the solar system. Titan is particularly intriguing because it has a thick atmosphere composed primarily of nitrogen, with lakes and rivers of liquid methane and ethane on its surface. This makes Titan one of the few places in the solar system with liquid bodies on its surface. Another notable moon is Enceladus, which has gained attention for its geysers that spew water ice and other materials into space. These geysers suggest the presence of a subsurface ocean, making Enceladus a prime candidate in the search for extraterrestrial life. The ice particles from these geysers contribute to Saturn's E-ring, creating a fascinating connection between the moon and the ring system. Saturn's other moons, such as Mimas, Rhea, and Iapetus, also offer intriguing features. Mimas, often referred to as the Death Star moon, due to its large crater Herschel, has a significant influence on the structure of Saturn's rings. As we continue our exploration, we'll delve into the missions that have significantly expanded our understanding of Saturn and its moons. Our understanding of Saturn has been significantly enhanced by several key space missions. The first close-up images of Saturn were captured by Pioneer 11, which flew by the planet in 1979. This mission provided the first detailed images of Saturn's rings and discovered the planet's faint F ring, setting the stage for future explorations. Voyager 1 and Voyager 2 followed, flying by Saturn in 1980 and 1981 respectively. These missions provided a wealth of data, including detailed images of the rings, moons, and atmosphere. The Voyagers discovered new moons, observed the complex structure of the rings, and provided the first close-up views of Titan. The most significant mission to date is the Cassini-Huygens mission, which arrived at Saturn in 2004 and spent 13 years orbiting the planet. Cassini's extensive observations have revolutionized our understanding of Saturn, revealing intricate details about its ring structure, discovering geysers on Enceladus, and providing unprecedented views of Titan's surface. These missions have transformed Saturn from a distant, mysterious world into a well-studied planetary system, rich with complexity and wonder. Saturn's physical characteristics set it apart from other planets in the solar system. One of the most notable features is its low density. Saturn has a density of just 0.687 grams per cubic centimeter, which is less than the density of water. This remarkable property means that if there were a large enough body of water, Saturn would float. Another distinctive characteristic of Saturn is its oblate shape. The rapid rotation of the planet, completing a full rotation in just about 10.7 hours, causes an equatorial bulge. This means that Saturn is not a perfect sphere, but rather an oblate spheroid, with its equatorial diameter significantly larger than its polar diameter. The difference between the equatorial and polar diameters is about 10%, making Saturn the most oblate planet in the solar system. The planet is composed primarily of hydrogen and helium, with a small core of heavier elements. As we wrap up our exploration of Saturn, we'll delve into the mythological background of the planet's name, adding a cultural dimension to our scientific journey. Saturn's name has deep roots in mythology, reflecting the planet's long-standing significance in human culture. The name Saturn is derived from the Roman god of agriculture and time, known for his golden age of peace and prosperity. In Roman mythology, Saturn was the father of Jupiter, the king of the gods, and his reign was marked by abundance and harmony. The mythological Saturn is often associated with the Greek god Cronus, who was the leader of the Titans and the father of Zeus. Cronus is a complex figure symbolizing both the destructive and creative forces of time. His story involves overthrowing his own father, Uranus, and eventually being overthrown by his son, Zeus. This cycle of power and renewal is a recurring theme in various mythologies and reflects the ever-changing nature of the cosmos. Saturn's rings and numerous moons have inspired countless myths and legends throughout history. Ancient civilizations often saw the rings as symbols of unity and eternity, while the moons were sometimes viewed as celestial bodies with their own unique stories. Understanding the mythological background of Saturn adds a rich cultural layer to our scientific exploration. Thank you for joining us on this exploration of Saturn. We've journeyed through the planet's basic characteristics, its thick atmosphere, and its magnificent ring system. We've delved into the powerful magnetosphere, explored the diverse moons, and learned about the significant missions that have expanded our understanding of this gas giant. Saturn continues to be a source of wonder and intrigue, offering endless possibilities for discovery. Stay tuned for more cosmic journeys, and don't forget to like, share, and subscribe for more fascinating space content. Until next time, keep looking up and marveling at the beauty of the cosmos.
You need to watch this if you want to discover life's hidden gems. Join our channel for tips, tricks, and secrets to live your best life. Like and subscribe to start your journey today.